And so if you want to start, go ahead.
I believe the first part of this talk is Ryan, right? You there, Ryan?
Ryan, if you could unmute yourself, you're muted.
All right, thank you. So I'll start this talk now on how to deliver open system firmware with Ron Minnick and myself. So the purpose of this talk is to go over what open system firmware actually is. We'll review the transition schedule as well as the OSF checklist. And Ron will go over a few examples of OSF compliant solutions and give some demonstrations on how to build them. Then we'll have the break and followed by a discussion. We have a few discussion topics lined up. I'm not too sure how well this will work with the tooling. Maybe we'll invite some people back into the Slack channel to talk on these discussion topics, but we'll see. We'll go ahead from here. All right, so what is open system firmware? So it's been an OCP project since 2018. The incubation committee representative is Ron Minnick. The volunteer project leads are myself and Reddy. You could find more documentation on OSF on the following wiki. And I encourage you to open this up and follow along in the checklist or the charter as we go through these items. So the three most important documents you should familiarize yourself with is the charter, the transition schedule, and the checklist. I'd actually say the checklist would be the most important. All right, so here's a brief overview of the transition schedule. So it was first proposed in the Global Summit back in 2019. And we went through a few milestones. We're currently in 2020. We finalized the OSF checklist. It's currently version 1.1. And the current rolling plan we have now is to make OSF required by March of 2021 for OCP. All right, so this is a link to the checklist. There you'll find a Google Doc. In the Google Doc, you could put comments or you could ask questions on specific items, or if you could suggest improvements as well. And as we said, this checklist will be, all the items on it will be required for open system firmware certification. And it's been developed this year and recently finalized in October. There are 9 sections in this checklist. 4 of them I'll go over in detail today. Most notably the licensing and redistribution, the ownership and reusability, the build system, and the test regime. So an area where lots of people are a bit uncertain is the difference between open source firmware and open system firmware. So this project is called Open System Firmware. You'll see it mistyped here and there, but it is open system firmware. We don't require the whole firmware to be open source. Binary blobs are permitted as long as those binary blobs are redistributable. This is really the only way we can make this project feasible. It would be too much of an ask to require all firmware to be open source by March of 2021. So where does this checklist apply? It applies to all firmware approaches, so EDK2 to core boot, Linux boot, any firmware you can put on the machine. However, it's restricted to the host firmware. So it doesn't apply to the like embedded, like the voltage regulators. It doesn't apply to the BMC, and it only applies to compute and storage servers as well as networking servers. So, for example, on a server, it might apply to the main x86 processor or the main ARM processor or the main power processor, not the BMC and other parts. So where does it not apply? So OSF submitters, they're free to include additional features as long as they meet the OSF requirements. So they can include additional features for what we call a value add. And those can be proprietary. They don't have to be open source, as we mentioned earlier. It does not prescribe what can be used in production environment. So for example, as long as the server has an option to install OSF firmware on the machine, you can choose to go with a proprietary solution when you put it into like a data center or production environment. There's no restrictions on what you install on the machine. It's just to make the option for open system firmware available for that server. And like we mentioned, doesn't apply to embedded controllers on the machine, doesn't apply to the BMC. All right. So in the checklist, we'll go over three. There's a lot to digest, but we'll go over the three key requirements. One is you can construct the firmware. Two is you can install the firmware on the machine. And three is you can redistribute the firmware that you constructed or you installed on the machine. And like we mentioned before, the firmware doesn't necessarily have to be open source. So you can construct it from a bunch of constituent binary blobs. So this is verbatim the wording from the checklist. The top level build script shall be the only script needed to be run to fetch all source code. We call it construction because we don't want to imply you can only build it from source code. The top level build script may invoke other scripts as well. The whole process, the build process doesn't have to be in one script. So for example, your top level build script can invoke the EDK2 build system or other build systems. As well as the build and update utilities, they must also be open source. So for example, if you need to use flash ROM to flash the machine, that's sufficient. The flash ROM utility is open source. It's also sufficient it's also sufficient for it to be a binary, which is redistributable for at least Linux or Windows. Yeah, so that's an OR. So your whole build system could run on Windows, and that would be acceptable from the OSF standpoint. All right, so the Open Compute project, they set up a Git repository for open system firmware with the following structure. So each submission would be under a vendor, product, and version triplet, like a in that directory structure. And it would include a license and a top-level build script. But do note, not all the source code should be in this repository. And we would recommend not putting all the source code in this repository. For example, if you depend on core boot, you would instead link to the core boot repository, and we'd recommend that. And the description here gives some more details. So the next key component is you can install the firmware. So the open source software must exist to update the firmware, or sufficient public documentation exists to rate such software. So like I mentioned, flash ROM, DP command, UEFI update capsule. But the mechanism for installing the firmware shouldn't be proprietary. It should be open source or documented in such a way that an implementation, so open source implementation, could be written for it. And the big challenge is one-time fuses. So this is the other aspect of installation, which is a lot of machines have a setup where you can only flash the firmware if you have it signed by the manufacturer. This has been a huge topic during the OSF calls, exactly how we can work with this. There's a trade-off between security and ownership that we're potentially making here. But essentially, the key problem is you might purchase a machine from the OCP marketplace, and you own the physical machine, but you might not own the firmware itself. You can't actually flash new firmware on it. Only the vendor has permission to sign the firmware and flash it onto the machine. So essentially, the manufacturer still owns the firmware on that machine, and the only way to flash it would be to send the firmware to the manufacturer and have them sign it, which is pretty much impossible to do. So this is the exact wording we came up with in the OSF spec. So this is a bit to digest, but the key component here is you could change ownership at least 8 times. The number 8 is fairly arbitrary, but we think that's sufficient for the purposes of OSF. So essentially, you can purchase a machine, you can flash your own firmware on it. When you sell the machine to someone else, they can flash their firmware and so on. So this is going to be a topic which will be discussed. The OCP security group says they want to review this requirement in the OSF spec. And if you're interested in that review, I recommend that you join they call it the OSF and security group harmonization open discussion, which lasts 2 hours on Friday. And a number of key speakers from the security group will be there to discuss the relation between OSF and security, especially this topic on ownership. OSF, currently, we don't have a very firm definition of what a firmware owner is. If you look at the OSF checklist, it's fairly vague, and we might want to discuss ways of improving the definition of an owner to meet our purposes. And finally, the last key component is you can redistribute the firmware. So it's not tied to the purchase of the hardware. So this differs from the previous key component. It differs from ownership in the sense that this is more tied to licensing. So sometimes you could purchase the hardware and you could download the firmware from the manufacturer's website, but you can't actually redistribute that firmware freely, which is the goal of this requirement, which is that you can redistribute the firmware from anyone to anyone without any restrictions like which prevent circular economy. So this is the exact wording that we have in the OSF checklist. OSF is open source by default. So closed source items are allowed given an improved and reasonable exception reason, such as containing silicon IP. Each closed source item must be redistributable, included in the submission, and reasonably granular. It is strongly encouraged but not required that every severable firmware component be so documented. So there's 2 fairly vague things in this sentence. You'll notice a reasonable exception reason, as well as reasonably granular. And I hope we can discuss later today in the discussion exactly what these 2 things should mean when the OSF group should accept a reasonably exception reason and when they should not accept it, as well as how should they accept a granular binary blob versus a non-granular binary blob. That's still open to debate, and hopefully we can debate that in the upcoming discussion. All right, so with all that in mind, We currently, during the submission process, only require a list of collateral be submitted. So this includes the firmware image, it includes the source code, the binary blobs, the documentation, tooling, etc. But a big challenge we face is it doesn't include, we don't include any means for the OSF community to verify that the firmware that is provided in submission actually boots on the hardware. So it brings up another number of questions like, can Linux boot? Can the firmware support multi-core systems? Is all of memory initialized? Things which you might not see in an open source or open system firmware solution, which you would expect. So this is a current concern to a number of people in the OSF community. And there's been a few proposed solutions to this. So one solution is self-certification. So the OSF community would define a test plan, so a list of tests which the vendor is required to run. So the vendor would be responsible for implementing these tests, running the tests, and providing results along with the submission process. So in this case, we would have to completely trust the vendor that they ran these tests correctly, and as expected, they ran it on the firmware image that they provided. We would also have to trust that their ownership model is how they describe, because they'd be signing their own keys. They could easily accidentally make a mistake where they have something like an ownership model which is incompatible with OSF and not realize. So this is currently for March 2021. It is self-certification. The OSF spec says it's a very simple test plan. It says you must reboot the machine 100 times without issues and provide those test results in the submission. So it's fairly simple, a test that you could probably run in 12 hours. It's probably a test that many vendors already run, so not very difficult. But the big challenge is many people in the OSF community feel this is insufficient, which is why there's proposals for other solutions. So the second option is the vendor provides a server to OCP for the purpose of testing by the OSF community. And the community would delegate the task of testing to a firmware testing partner to run the test plan. In the previous talk, 9 Elements mentioned that they're going to propose a more in-depth and research a more in-depth solution along these lines. And they're also considering becoming what we'd call a firmware testing partner or a firmware testing individual, or we'll come up with an agreed upon term. And the hardware must have all of the components populated sufficient for running the tests. So for example, if it's a multi-socket system, it must have CPUs in all the sockets. It must have some memory. It must have flash chips in order to test. So this is one proposal, and one of the big challenges we face in this proposal is how will this be incentivized? So would you require the vendor pay the firmware testing partner for this service? Who would store the machines with the firmware testing partner? Store the machines with OCP? Exactly how would it work? And 9 Elements is currently researching this. And a third option is, so rather than go through this logistic hassle of shipping servers around the world, instead the vendor could provide remote access to the servers which need to be tested, and the OSF community or some members of the OSF community, or possibly a individual testing partner, would be able to remotely access these machines with the capabilities to reflash the firmware, possibly through a BMC or something like a flash programmer they'd have the ability to power cycle, access the network on the server, access the serial, and they'd be able to test the OSF submission through those means. So this is another option. So hopefully during the discussion later today, we can discuss which of these options would be preferred, how we could incentivize testing partners to test the machines, etc. So in summary, so before I hand off to Ron, the summary is the current OSF transition schedule targets March 2021 for being required for OCP acceptance. The three main goals of the OSF checklist is you can construct the firmware, you can install the firmware, and you can redistribute it. If you don't read the entire checklist, I want these three things to be your main takeaway. And there's also a number of OSF compatible solutions that you could use today, such as Coreboot, EDK2, IBM Power, in platform, they all have OSF solutions today. All right. And of course, find these documents on the wiki, join the mailing list, join the bi-weekly calls, and also fill out this questionnaire if you're interested in attending these calls from a different time zone. You might not be able to type this all in, but you could find a link to the questionnaire from the first link from the wiki. All right, I'll hand this off to Ron now.
So question here, am I visible?